Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at an AriserTalent. AriserTalent is an e-learning platform where you can get the video lectures recorded by the expert faculty of the Kota, along with the content related to CBSE, NTSE, NEET and JEE. You will also get the sample papers along, so time to time you can analyze your performance, and along with that we are also provided with the doubt section, so you can comment your doubt and the faculty will answer you within 24 hours. So what you have to do, you have to just subscribe our channel for getting more amazing videos like this. So just press the bell icon and subscribe our channel. So what we were discussing about a chapter number 1st of the physics, that is about the light reflection and refraction. And in our previous lecture, we have discussed about the types of lenses. So what are the two types of the lenses we have? Convex and concave lens, and we have learned about the terms that are related to this topic, that is about the principal focus, optical center, and what will be the focal plane. Now in today's lecture we are going to deal with a very interesting and important topic, and this is very important from your exam point of view, and it is all about the image formation by the convex and concave lens. So let's see how will be the image is going to be formed by convex and concave lenses. So our topic is all about image formation by convex and concave lens. So in our today's lecture we are basically going to deal with this topic, that how the image will be formed in case of convex and concave lens. But before that, just see what will happen when a ray of light is incident at a different points in both the lenses. So firstly, we are considering the convex lenses here. So what will be the convex lenses? Convex lenses are those lenses which are thicker in the middle and thinner at the edges. It means both the surfaces are bulging outwards. So firstly, let's see what will be the image formation in case of convex lens. Now, firstly, I am considering that a ray of light in a convex lens is incident on a focus. So what will happen when a ray of light is incident on a focus? It will, after refraction, it will going to pass through the lens and it will go parallel to the principal axis. So what will happen in the first case? Suppose our case number 1 is ray of light is incident on principal focus. So this is our first case, that a ray of light is going to incident on the principal focus. So for this, I am just drawing the convex lens here. This is our convex lens. This is our principal axis. Now, a ray of light is going to be incident on the principal focus. So, if a ray of light is going to incident on the principal focus, it will go parallel to the principal axis. So, if I am drawing the focus of a mirror like this will be focus. And suppose a ray of light is coming in this manner. If a ray of light is incident like this, then after refraction through the mirror lens, it will go parallel to the principal axis. So you can see that when a ray of light is incident at a focus, it will going to direct parallel to the principal axis after refraction. So this is our principal axis and a ray of light is going parallel to the principal axis. Now, case number 2. Case number 2 is when a ray of light is incident at an optical center. It means ray of light is incident on optical center. Now, if ray of light is going to incident on the optical center, what will happen in this case? Suppose this is our convex lens. This is our principal axis. And what is the optical center? Optical center will be this. When we pass a ray or when we incident a ray on the optical center, what will it will do? It will just pass through the lens without any deviation. It means if a ray of light is going to be incident on the optical center, then without any deviation, it is simply going to pass through the lens. So this is how in case of convex lens, the ray of light is incident on the optical center will going to behave. So it will behave like that. If it is incident on the lens, it will simply pass through the lens without any deviation. So this is the case in case of the optical center we have. Now, our case number 3. Case number 3 is when a ray of light is going to incident parallel to the principal axis. It means the ray is coming parallel to the principal axis. So, if ray of light is incident parallel to the principal axis, where will be the ray go after refraction? Let's see in the diagram here. This is our convex lens. Again, this is our principal axis. Now, if a ray is incident parallel to the principal axis, so I am assuming that a ray is coming parallel to the principal axis. Then after refraction, the ray is going to pass through the focus. These are the two just opposite cases you have seen. When a ray is coming to incident on the focus, it will go parallel to the principal axis after refraction. But when a ray is coming parallel to the principal axis, then after refraction, it will going to pass through the focus. So these are two just opposite cases, that is case number 1 and case number 3. So after refraction, the ray is going to pass through the focus. So if I am considering this is our focus, so the ray of light is going to pass through the focus. So this is how the ray in case of convex lens will look like. So here we have the 3 cases that when a ray is incident on the focus, it will going to pass through the principal axis. When a ray is passed through the optical center without any deviation, it will simply refract it. When a ray is coming parallel to the principal axis, it will going to refract at the focus. So here we have the 3 cases in case of the convex lens. Now, where will be the image formed in case of the convex lens? It is basically dependent upon the distance from the optical center. Because in case of the mirrors, we have seen that the pole is very important. But in case of the lenses, what thing is important? We have a one important thing, that is about the optical center. So the complete things will depend upon the optical center and how will be the image formed. Let's see here. So before that, just copy this part from here. Now, let's see where will be the image formed in case of convex lens. In case of convex lens, you will always get real and inverted image. So mostly convex lens is going to form real and inverted image. So this thing you have to kept in your mind that convex lens is going to form real and inverted image. Now, where the object is placed, where the image is formed and what is the nature of the image, let's see in the table, and you have to learn this table for simply solving the problems, because the questions can be asked in your exam that where will be the image formed and what will be the nature of the image. So for this you have to understand this table. So for making this table, firstly we are taking position of object. Here we are taking position of object, position of image, and then we are taking nature of image, these are the three things we have to consider here: position of the object, position of the image, and what will be the nature of the image. And lastly, we have to consider the size of image. So these are the things we have to consider here in all the cases. So the first thing is about the position of object, second is position of image, third is the nature of image, and the fourth one is the size of the image. Now, let us see the first case. The first case is when you place the object at infinity. What is the position of the object here? You have placed the object at infinity. If you place the object at infinity, you have to remember that the image is going to be formed at the focus. So what will be the position of the image? Image will be formed at focus. Now, the nature of the image is that the image will be highly diminished. Image will be highly diminished and it will form the real and inverted image because it is a convex lens. It will form real and inverted image and the image will be highly diminished. So, this is the first case we have. So you have to keep in your mind, when you place the object at the infinity, image is going to form at the focus, and when you place the object at focus, the image will be going to form at the infinity. So this is the first case we have. Now, second condition, you are placing the object between F and 2F. So object is placed between F and 2F. So when you place the object between F and 2F, you will get the image between F and 2F. So similarly, you will get the image wherever you place the object. So similarly, we will get the image between F and 2F. And the image again formed is real and inverted, but in this case, the image is bit diminished. It is not highly diminished. It is only bit diminished. So we will get the real and inverted image. And the image in this case will be diminished. So this is our case number 2. Now, what we are doing in our third case, we are just placing the object at 2F. We are placing the object at 2F. If you are placing the object at 2F, the image will be similarly formed at 2F. And image formed is of the same size as that of the object. But again, you will get the real and inverted image. So again, we are getting the real and inverted image. But what is the condition here? You will get the same size of the image as that of the object. So we will get same size of the image. Now, case number 4. In case number 4, what we are doing, we are just placing the object at focus. We are placing the object at focus. Now, if the object is placed at the focus, where will be the image formed? The image is definitely going to form at infinity. Image is going to form at infinity. And what will be the nature of image? The image will be highly magnified. The image will be highly magnified, and again you will get the real and inverted image in this case. So what we will get? We will get the nature of the image is real and inverted, and you will get the highly diminished image, highly magnified image. Real and inverted, and this image will be highly magnified. So this is the case when you place the object at focus. Now, next case is when you place the object between optical center and focus. So we are placing the object between O and F. So where will be the image formed? The image is going to be formed between O and infinity. Image will be formed between O and infinity. Now, this is the exception here. You will get the nature of the image that is virtual and erect. You will get the image that will be virtual and erect, and this time you are getting the image that will be magnified only. So what you will get here? You will get the magnified image in this case. So this is the only exception you have where you are getting the virtual and erect image. Otherwise, in case of the convex lenses, we are always getting real and inverted image. So this is the image formation in case of the convex lens we have seen. Now, just copy this table from here because it is a very important one. So we can deal with concave lenses. So just copy this part from here. So these are the cases you can see here that when you place the object at infinity, the image is going to form at the focus. When you place the object between F and 2F, so in this case, where will be the image formed? Correct this statement here, that the image is going to form beyond 2F. The image is going to form beyond 2F. And if the image is going to be formed beyond 2F, the image will not be diminished, it will be magnified here. And one more case you can conclude from here, which is just opposite to that. If you place the object beyond 2F, you will exactly get the image between F and 2F. So image will be obtained between F and 2F, and what will be the nature of the image? Again, the image will be real and inverted, but the image will be diminished in this case. The image formed will be diminished in this case. So you are getting the diminished image. Now, if you place the object at 2F, you will exactly get the image at 2F, and it is of the same size as that of the object. If you place the object at focus, you will get the image at infinity, and this will be highly magnified in this case. Now, if you place the object between O and F, what is O? O is our optical center. So you will get the image on the same side between O and infinity, and that image will be virtual and erect, and this is the only exception we have. Now, this is just opposite case of that of the second one. When you place the object beyond 2F, you will get the image between F and 2F, and it will be diminished, and again it will be real and inverted. So these are the cases in which the image formation is going to take place in case of convex lenses. Now, the second type of the lenses we have is concave lenses, and let's see where will be the image formed in case of concave lenses. So we have the image formation in concave lens. Now, concave lens is always going to form the virtual and erect image. the nature of the image will be virtual and erect. It is going to form the image which is virtual and erect. But before that, just see what will happen when a ray is going to be incident on the principal axis and when the ray is going to be incident on the optical center. So again, we have the two cases here. So the first case is when a ray is incident parallel to principal axis. So this is our first case, that a ray of light is going to incident parallel to the principal axis. So what we are discussing now, we are going to discuss about the concave lenses. So I am drawing the concave lens here. This is our concave lens which will be depressed inwards. This is the principal axis in case of the concave lenses. Now, what is the condition? The condition here is a ray of light is coming parallel to the principal axis. So this is our principal axis and a ray of light is coming parallel to the principal axis. This is the ray of light. Now what will happen? After refraction, the ray is going to pass through the focus. It means it will come to the same side after refraction. It means it is in the same side as we are passing the incident ray. So after refraction, the ray is going to pass through the focus and the ray will be somewhat like this. So you can see that when a ray is incident parallel to the principal axis, in case of concave lenses, the ray is going to pass through the focus on the same side of the lens. So the ray is coming to pass through the focus within the same side of the lens. So this is the condition. That is the first case we have. Now our case number 2 is when a ray of light is passed through the optical center. It means when a ray of light is incident on optical center. If ray of light is incident on the optical center, what will happen? Let's consider the second case here. So again, I am drawing the concave lens here. Now this is what? This is our principal axis. And what is the optical center here? The lens having a center, that is the optical center. When a ray of light is incident on the optical center, without any deviation, it will going to pass through the lens. So what will be the case here? It is the same case that we have discussed in the convex lenses. It means when a ray of light is incident on the optical center, without any deviation, it is going to pass through the lens. So this is the second case we have. So this is our case number 1 and this is our case number 2. So we have the two cases in case of the concave lens. So this is how the ray is incident on the concave lenses. Now what will be the nature of the image formed by the concave lenses? So concave lens is always going to form the virtual and erect image, and convex lenses are forming real and inverted image. So what will be the nature of the image? What will be the size of the image and where the object is to be placed? Let's discuss. Again, the same table we have discussed in the convex lenses. So the first thing is about position of object. Here we have to write the position of object. Here, position of image. Then, nature of image. And lastly, what will be the size of the image? Now, case number 1 is when you place the object at infinity. Now, it's very common question. Whenever you place the object at infinity, where will be the image formed? Can you tell me where will be the image formed? The image will going to to be formed at the focus only. So, again, the same thing is occurring here. When you place the object at infinity, the image is going to form that focus. Image will be going to form at the focus. And what will be the nature of image in case of the concave lenses? The nature of the image will be that it will be virtual and erect. And what will be the size of the image? The size of the image is that it will be highly diminished. It will be highly diminished. Now, case number 2. Case number 2 is that you are placing the object between O and F. You are just placing the object between O and F. Then where will be the image formed? Image is going to be formed between O and infinity. And again, the nature of the image is that it will be virtual and erect. The image is virtual and erect. And the image formed in this case will be diminished one. So, the image formed is diminished here. So, we are having just 2 cases in case of the concave lenses, and you have to remember these 2 tables for solving numericals also, and always the question may be asked from this part in your exam, that where will be the image formed and what will be the nature of the image. So, you can see that convex lenses are forming real and inverted image, and concave lenses are forming virtual and erect image. So, in our today's lecture, we have a great discussion about the image formation by the convex and concave lens. So, this lecture is over here. We will deal with many more interesting topics in our next session. So, thank you so much and have a wonderful day.